Now let's move on to the next concept, that is the lattice energy. What is this lattice energy or the lattice enthalpy? Lattice energy is defined as the amount of energy required to break 1 mole of an ionic crystal into its constituent oppositely charged gaseous ions. So, what is the amount of energy required to break or to convert 1 mole of the ionic compound or ionic crystal into its constituent ions, that is the positive as well as the negatively charged ions? Or it is nothing but the amount of energy released when oppositely charged ions, oppositely charged gaseous ions combine to form 1 mole of ionic solid. So what is the amount of energy released when oppositely charged gaseous ions combine to form 1 mole of ionic solid? For example, 1 mole of sodium ions and 1 mole of chloride ions, when they combine in the gaseous state in order to form 1 mole of solid sodium chloride. So what is the amount of energy released in this process? And that energy is called as the lattice energy. And this lattice energy of an ionic crystal we cannot calculate directly based on the experiment, and that we can calculate using Born-Haber cycle. So we cannot calculate the lattice energy in an experiment. What we can do is we can use a concept called Born-Haber cycle to calculate the lattice energy. And this Born-Haber cycle is based on a concept called Hess law. The Born-Haber cycle is based on Hess law, and according to this particular law, the heat changes are same whether the chemical reaction proceeds in single step or in several steps. What it is? The heat change involved in a chemical reaction is same whether the reaction proceeds in one step or through several steps. For example, whenever there is a reaction which is taking place directly in one step, or whenever it is taking place in individual 3 or 4 steps, so what is the total energy involved in this one single step? It will be always equal to the total energy involved in all these steps together. So the total energy change in any chemical reaction always remains the same whether the reaction takes place in one step or it takes place in several steps. That is the concept of Hess law. And we use this Hess law in this Born-Haber cycle in order to calculate the lattice energy. Let's take an example of formation of sodium chloride. So how sodium chloride is formed? So whenever we take the case of oppositely charged gaseous sodium ions combining with Cl- ions again in the gaseous state, that results in the formation of 1 mole of ionic compound sodium chloride. And in this process, the amount of energy released, that is equal to 758.7 kilojoules per mole. So what is the lattice energy of sodium chloride? That is equal to 758.7 kilojoules per mole. So when we write a negative form, negative sign, it indicates that that process is exothermic in nature. Let's do the individual calculations here. So let us do the first step, that is the direct method. Whenever in the direct step, the sodium is combining with chlorine to form the sodium chloride. So solid sodium which is available in that form combines with the gaseous chlorine in order to form sodium chloride ionic crystal. Some amount of heat is released in this process, and that particular heat we call it as a heat of formation or enthalpy of formation. Remember, I simply explain the word enthalpy. Enthalpy is nothing but the total heat content of a system. This is a word we come across in thermodynamics. The total heat content of a system at a given temperature and pressure, that is called as the enthalpy. So it is nothing but the heat of formation of NaCl, the amount of heat released in this process. We call it as enthalpy of formation or heat of formation. So when we write the equation, it is like this. Now we are taking sodium in the solid state, that is combining with chlorine which is in the gaseous state, and that results in the formation of solid sodium chloride, isn't it? And in order to balance the equation, we take half mole of chlorine gas. And in this process, the amount of energy released, we represent with delta HF, that is heat of formation. And that value is equal to minus 381.8 kilojoules per mole. So generally, we will never prefer to learn the values. But if you are writing your board level examinations, it is better always to learn at least the values for formation of the sodium chloride crystal. And in objective entrance examination, they will give some hints or some values in order to calculate the lattice energy. So that is how sodium chloride is formed directly in one step. Let us see when it is done when it is taking place in several stages, what is happening. So whenever it is taking place stepwise, here 5 stages are included. So one is the formation of the gaseous sodium. Solid sodium is converted into gaseous sodium by absorbing energy. and the energy required for this process is called as sublimation energy. What is the meaning of sublimation? The conversion of a solid directly into gas, that is called as sublimation. So here what we are doing is the solid sodium is converted into gaseous sodium. So this is an endothermic process. The energy required for this process, that is delta S, indicates sublimation energy. As it is endothermic, it's a positive value, that is 108.5 kilojoules per mole. That is sublimation energy. So after the conversion of solid sodium into gaseous sodium, what happens? It is a formation of the gaseous sodium ion. So the gaseous sodium atom loses an electron and it is converted into gaseous sodium ion. So sodium atom, when we take one atom, if it loses electron, that converts into sodium ion. So for that one we require some amount of energy, and that energy is called as ionization energy. So how we write the equation? Gaseous sodium atom, after losing one electron, that is converted into unipositive ion. And in this process, the amount of energy required or used, that is called as ionization energy, and that is equal to 495.2 kilojoules per mole. The value is 495.2 kilojoules per mole. So in order to form the sodium chloride ionic compound, already we got sodium ion. Now we need to see the formation of Cl- ion. Here it is. Formation of the gaseous chlorine atom first. So the gaseous chlorine molecules are dissociated into gaseous chlorine atoms. So molecules are dissociated into chlorine atoms. So as molecules are broken down into atoms, we need some amount of energy. And the energy required to break these bonds, we call that one as dissociation energy. So the energy absorbed in this process, that is called as the dissociation, or the bond dissociation energy of chlorine. So when we take chlorine in the gaseous form, that is to be broken in order to get the individual chlorine atoms. The energy required for this process, that is called as the dissociation energy. As here in this equation we require only 1 mole of chlorine atoms, what we do is we take only for half mole of chlorine gas. So we get 1 mole of chlorine atoms. And the energy here, whatever we use, it should be half of the dissociation energy, isn't it? The value is not for per mole, it is only for half of the mole. So that is the reason why we get the value as 121.5 kilojoules. It is for 1 mole of chlorine, the value is 243 kilojoules per mole. Remember, it is not for 1 mole, it is for half mole. This is a place where you may do some wrong calculation. Next, after the formation of gaseous chlorine atom, what we get? We need to convert that one into the chloride ion. So the gaseous chlorine atom gains an electron and converts into gaseous chloride ion. So as the process of conversion of a neutral atom into its negative ion is exothermic in nature, energy is released in that process. And what is that energy called? That is called as the electron gain enthalpy. So whenever chlorine in the gaseous form, if that is accepting electron, that is converted into Cl- ion. That is converted into Cl- ion. And the energy released in this process, we represent with delta E, that is electron gain enthalpy or electron affinity. And that value is equal to minus 348.3 kilojoules per mole. So next, in the last stage, formation of sodium chloride crystal takes place. So the gaseous Na plus ion combined with the gaseous Cl- ion in order to form NaCl ionic crystal. And in this process, some amount of energy is released, and that energy is called as the lattice energy. So Na plus ion combines with Cl- ion both in the gaseous form, that results in the formation of solid sodium chloride crystal. And the energy released in this process, for a moment I will keep it as question mark, that is the lattice energy, what we are calculating in this particular example.